Here we have AP calculus AB problem. Okay, let's go to the question. Solve the differential equation. Use C for the concept of integration. Okay, solving the given differential equation means we have to solve for the variable y in terms of x. Okay, in my first step, what I'm going to do is I'm going to get rid of this dx in denominator because my aim is to solve for y. So I keep dy on the left side. I want to get rid of the dx that we have in denominator. So for that, what I'm doing is I'm multiplying both sides of the given differential equation by dx. When I do so, this dx will cancel out. I'm getting dy equals to x negative 2 over square root of x square negative 4x positive 7 times dx. Okay, if I want to solve for y in this dy, what I have to do is I have to get rid of this d. Actually, this d refers to derivative, that is derivative of y. So if I want to get rid of the derivative over here, what I have to do is I have to integrate. That is, I have to integrate both sides of this equation. When I integrate this dy, I'm just getting y on the left side. Okay, now on the right side, I have to integrate this function with respect to x. So how do I have to integrate this one? Actually, this is a little complicated. So let's consider the denominator we have over here. So the denominator contains a square root, and inside the square root we have an expression. Okay, so this is a troubling part. Instead of having an expression, if I just have single variable inside the square root in denominator, so it will make the integration process easier. So instead of this expression x square into 4x positive 7, I just need a single variable inside the square root. So what should I do? So I have to introduce a new variable for this expression x square into 4x positive 7 to get a single variable inside the square root. So for that we have to do u substitution. So that is, I'm going to substitute a new variable u for this expression. Let me do this separately. So let u equals to x square negative 4x positive 7. Okay, so whenever I introduce a new variable for the part of the function we have in the integration over here, this complete integration we have to get it in the new variable u. So for that we have to get du at the place of dx. So here we have already u. So instead of dx, if I want to get du, what should I do with this u? So I have to find the derivative. So here we have the original integration with respect to the variable x. So here to get du, what I have to do is on both sides of this equation, I have to find derivative with respect to x. When I find derivative of u with respect to x, I am getting du over dx. When I find derivative of this x square, I am getting 2x negative. When I find derivative of this 4x, it's just 4. The derivative of the constant positive 7 is 0. Okay, now to solve for du in this equation, we can multiply both sides by dx to get up the denominator over here. Let me multiply the right side also by dx. This dx will cancel out. I'm getting du equals to, and also when I look at the stuff 2x and 4 over here, both 2x and 4 have the greatest common divisor 2, so we can factor 2 out. If 2 is factored out, what do we get inside the parenthesis? We get x negative 2 times dx. Even if I distribute this 2 to this x and negative 2, I'm getting this stuff. Okay, now let's come back to the original integration we have over here. So when I consider the original integration we have over here, so for this one, for x square into 4x positive 7, I mean for the expression we have inside the square root, we can substitute because that is what we have assigned for this expression. And also in numerator we have x negative 2 times dx. So here we have x negative 2 times dx, but along with that we have 2 multiplied. Since we have only x negative 2 times dx over here, we have to get rid of this 2 over here. For that, what I have to do is I have to multiply both sides by 1 over 2. Let me do it. 1 over 2 times du, 1 over 2 times x negative 2 times dx. Because my aim is to get rid of this 2 which is multiplied by over here. For that, I multiply both sides by 1 over 2. This 2 will cancel out. I'm getting 1 over 2 times du equals to x negative 2 times dx. Okay, now let me make rearrangements in the terms over here in this integration. So I just write this x minus 2 along with the dx using multiplication. In that case, I'll be getting 1 in denominator. That is 1 over square root of x square negative 4x positive 7. Now I'm going to write this x negative 2 along with this dx. Then I'm getting x negative 2 times dx. Okay, now we have y equals to integral 1 over. So now for this expression inside the square root, what we can plug in is we can plug in u and times. So for this x negative 2 times dx, what we can plug in is we can plug in 1 over 2 times du. Okay, now this is a variable part. It is multiplied by a constant over here. In integration, whenever the complete variable part is multiplied by some constant, what we can do is we can move it out of the integral. That is, this constant 1 over 2 can be moved out of the integration. So when I do so, I am getting y equals to 1 half times integral 1 over square root of u times du. Okay, now let me continue over here. y equals to 1 over 2 times integral 1 over. So we have square root for u over here. So whenever we have square root, it can be written as exponent. When I write the square root as the exponent, it will be 1 half times du y equals to 1 over 2 integral. Okay, now to integrate this stuff, what I'm going to do is I'm going to move this term to numerator. Whenever I move a particular term from numerator to denominator or denominator to numerator, the exponent will change its sign. Already it's a positive exponent. So when I move this term to numerator, it will become u to the power of negative 1 half times du. Okay, y equals to 1 half. Now we can integrate this u to the power of negative 1 half using the power rule of integration. That is, we have to add 1 to the exponent and divide the result by the same exponent. That is u to the power of negative 1 half positive 1 over negative 1 half positive 1. And since this is indefinite integral, that is, we don't have a lower limit and upper limit. So for an integral, when we don't have limits, it has to be considered as indefinite integral. Whenever I evaluate indefinite integral, for the result of the integral, I must add the constant of integration. According to the given information, we must use c as a constant of integration. So here to this result, I am adding the constant of integration c over here. Y equals to 1 over 2 times u to the power of, when I simplify this negative 1 over 2 positive 1, I'm just getting 1 over 2, and here the same in denominator, that is 1 over 2 positive c. So this 1 half will cancel out, then we get y equals to u to the power of 1 over 2 positive c. Okay, let me continue over here. Y equals to, since we have exponent 1 half for u, this exponent 1 over 2 can be written as square root, then I'm getting y equals to square root of u positive c. Actually, u is the variable taken by us. It has to be replaced by the original stuff, that is x square into 4x positive 7. Then I'm getting y equals to square root of x square negative 4x positive 7 positive c. So this is a solution for the given differential equation.